Okay, Rams. Sorry I'm absent today. I am home with the sick kiddo, so I wanted to quickly review the multiplying fractions and then get into the rest of our notes for this unit. We're going to knock them all out at one time, okay? So Friday, you worked with some groups and you were trying to figure out the rules. You did some research on your own, trying to find the rules for multiplying fractions, and we're just going to quickly review those. The rules were that you multiply straight across. So 2 times 9 was 18. 3 times 10 was 30. You simplify both of them. So you divide them both by 6. You get 3/5. Okay, this was also the one where you could use that strategy where you factor out numbers. And you say, I'm going to factor out the 3 of both of these, and I have a 1 and a 3. And I divide both of these by 2, and I have a 1 and a 5. This was from last week. So 1 times 3 is 3, and 1 times 5 is 5. Okay? A couple of things just to make for sure we remember is that no whole numbers. If I have a whole number, I must make it over 1, and then I still multiply straight across. So 6 times 2 is 12. 1 times 3 is 3. 12 divided by 3 is 4. Both of these must become mixed numbers. Improper fractions. They are mixed numbers. 5 times 4 is 20, plus 1 is 21 over 5 times, and then I have 2 times 2 is 4, plus 1 is 5 over 2. And then I multiply these, and I would get 10.5, okay? So when I go over here, this was the one that it was a lot about today's work. We kind of talked about it yesterday. When you have a fraction of a number, it means multiply. So 3/4 of 180 would be 3/4 times 180 over 1. So then you just multiply straight across and simplify. All right. So then, 3 times 180, 3 times 18 is the same as 9 times 6, so 540 divided by 4. So it's, 100 and something. 540 divided by 4. $135. Okay. How do you know it's multiplication problems? That's where we are at now. Okay, here this one says Susie's making cookies. The recipe calls for 2.5 cups of flour. You're doing a lot of these today. She wants to make 3 batches of cookies. So basically every batch needs 2.5 cups of flour. The first batch needs 2.5 cups. The second batch needs 2.5 cups, and the third batch needs 2.5 cups. So you solve it with repeated addition. So that means it's multiplication. 3 times 2.5. Okay, and then you would solve that. This one here, Lindsay's counting the students in the cafeteria. There are 240 students. 3/4 of these students are wearing RMS shirts. How many students are wearing RMS shirts? So basically, we want to know 3/4 of 240. Now, how I know that is that it tells me 3/4 and it says of these students. Well, what students? Of the 240 total students that we have, okay? And that's what tells me that it's multiplication. Okay, next page here. There's not a lot of writing, okay, but a couple of big ideas to think of, okay? Here I have 5 times 1 is 5. If I multiply something larger than 1, if I multiply 5 times 2, 5 times 3, 5 times 4, what happens to my answer? It gets larger. Okay, if I multiply by something smaller than 1, okay, so 5 times 1 is 5. So if this number is no longer a 1, it's anything less than 1. A 1/2, a 1/3, a 3/4, a 5/8, anything less than 1 whole, my answer gets smaller. Okay, so we have 3 basic rules here on your notes. Okay, the first one says that when you multiply 2 numbers that are less than 1, both of these are less than 1 whole, your answer must be less than both of them. It's taking a part of a part. Okay, number 2, when you multiply 2 numbers that are greater than 1 whole, That's a mixed number, and that's a mixed number. Your answer is greater than both of them. So a lot of times it would just say your answer is greater than 5 and 7/8 because that's the biggest. If it's bigger than that one, then it's also bigger than that one, okay? And the last one says that when you multiply one number that's less than 1 and one number greater than 1, your answer is somewhere in between them. That means my answer is greater than 3/4 but less than 2 1/8. Okay, because if I multiplied 2 1/8 times 1, I would get 2 1/8. But I'm multiplying it by something less than 1, so it's going to be smaller than this. Okay? So we're going to use these 3 rules to answer these 4 questions here and talk through them for a second. Okay? Which statement is true? Okay, the product of 7/8 and 3/4 is less than 3/4. Well, these are both less than 1 whole, and that one is 6/8, so it is smallest. That looks true to me. Okay. The product of 1 2/3 and 8/9 is less than 8/9. Well, that's greater than 1 whole, and that's less than 1 whole, so my answer should be between them. So that is not true. The product of 5/3 and 2/7 is less than 2/7. Well, that was a tricky one because that's improper. They're trying to trick you there. That is actually greater than 1 whole, so it cannot be less than 2/7. Then the product of 4/5 and 6/7 is greater than 4/5. No, because both of these answers are less than 1 whole, so my answer gets smaller. So that is A. Okay, this one here, okay, says, I'll zoom it in for you. Which of the following statements is true? 30 times 4/3, so that's greater than 1 whole, is greater than 30. So a number times something greater than 1 means it gets bigger. That looks true. Okay, this number is less than 1 whole. So 12 times 3/5 is greater than 12. No, it's going to be smaller than 12 because that's less than 1 whole. 15 times 6/5 is less than 15. Well, 6/5 is an improper fraction. Just a second, okay? 15 times 6/5, that's something that's greater than 1 whole. So my answer should be greater than 15. Same thing here. 18 times 7/6. That's greater than 1 whole, so my answer should be greater than 18. So that answer is A. Okay? If 45 is multiplied by m, which value of m will give a product less than 45? Means the answer will be less than 45. Well, for my answer to get smaller, that means I'm multiplying it by something less than 1 whole. 3/2, 3/10, 8/3, or 5/2. Well, 3 of those are improper fractions. The only one that's not, the one that's not greater than 1 whole is B. Okay? Which expression has a value greater than 3/4? Well, all of these start with multiplying by 3/4. So basically, which one of these am I multiplying by something greater than 1 whole? 2/3, 3/2, 1/2, or 7/8. So which of these is greater than 1 whole? 3/2. Okay? Next page is pretty easy one. Okay, this is about reciprocals. Okay, and basically a reciprocal is just when you flip a fraction upside down. You use these when you're dividing fractions, and we'll see those in just a second. This one's easy. You have a song there if you want to watch it later. Okay, no whole numbers, no mixed numbers, again, just like before. So the reciprocal for 4/5 would be 5/4. The reciprocal for 9/2 would be 2/9. The reciprocal for 1/5 would be 5/1, which is 5. Now, the reciprocal for 7, okay, well, that's a whole number, not a fraction, so I have to make it a fraction by putting it over 1, and now the reciprocal would be 1/7. Okay, this is improper. I mean, it's a mixed number, so we make it improper. 7 times 2 is 14, plus 3 is 17/7. So the reciprocal of that would be 7/17. I know these are going pretty fast. I'm just trying to help you get your notes filled out, and then we can do more with them tomorrow, okay? The reciprocal of 6/9 is 9/6. One last thing to notice down here on the bottom for this page, it's a pretty fast page. But you take a number and you take its reciprocal and multiply them together. Well, 5 times 8 is 40. What's 8 times 5? 40. The product of any number and its reciprocal is always going to be 1. That's kind of cool. Okay, last page. This is the one we're building up to here. Okay, so I know we're about 10 minutes in. I'm going to try to make it pretty fast for you. But to divide fractions, multiply the first number by the reciprocal of the second. Okay, we call that a lot of times keep, change, flip, and you may have heard that from elementary. That means keep the first number, change the division to multiplication, and use the reciprocal of the second. All right, one little phrase that was taught to me many, many years ago is dividing fractions is easy as pie. You flip the last and multiply. Okay, so we're going to do a few here to practice, okay? The first one, this first example is done for you. Okay? 3/4 times 1/8, divided by 1/8. So I keep the first one, change it to multiplication here. So my division went to multiplication, and I flipped the reciprocal of the last one. And now it's a multiplication problem. And we've been doing those for a few days now. So 3 times 8, 4 times 1, and then we simplify. Okay, we're going to do a few of these. So keep the first one. I'm going to write it as 6/1. No, not just 6 times. And the reciprocal of the second is 3/2. So I'm going to write it here. 6/1 times 3/2. 6 times 3 is 18/2. 18 divided by 2, always in simplest form, is 9. So if I wanted to know how many 2/3 go into 6, it's 9. All right, the next one here, 5/8 divided by 2. So keep the first one, change it to multiplication, flip the last one. So if this is 2/1, it's going to become 1/2. Okay? So 5/8 times 1/2. So top times top, bottom times bottom. 5 times 1 is 5. 8 times 2 is 16. So 5/16 is your answer because that is already in simplest form. All right, this one here is a mixed number. We need to make it improper first. So 6 times 2 is 12, plus 1 is 13. So that one is 13/2. Times, and then I use the reciprocal of this one, which becomes 5/4. So 13/2 times 5/4. Well, 13 times 5 is 65/8. I'm going to go right down here and do some division. You'll need to do the same thing. 65 divided by 8. 8 times 8 is 64. Now subtract and get a 1. That 1 becomes my numerator. My denominator is the same divisor over here. So it's 8 and 1/8. All right, we're almost done. Very last problem here. Mr. Atkinson has 5 1/4 pounds. He'll put each one into 3 equal containers. So 5 1/4 divided by 3. Show me that work, okay?